The broadcast is now starting. All attendees are in listen-only mode.
Hello, and thank you for joining us for the MVI69 MCM webinar. My name is Brian Gray. I'm a technical support engineer here at ProSoft. Been here for a couple years. So this is kind of give you a brief overview of what we're going to go over today. Start getting into some of the setup, go into some troubleshooting, and we'll go from there. So let's see. Next slide. The MVI69 MCM is a serial Modbus communication module for the CompactLogix. It also works with the MicroLogix 1500. It has two serial ports. They can be RS-232, 422, 485 independently. There's a 4,000 word database and a configuration port here. Typical applications. Modbus is pretty much everywhere. It's a really easy protocol. A lot of people use it, and it's in a lot of different places. So what we're going to go over today is adding the MVI69 MCM to a CompactLogix system, physically adding it to the rack, and then importing the add-on instruction, downloading to the ControlLogix or CompactLogix. Going over the configuration through the ProSoft configuration builder. We're going to set up one port as a master, one port as a slave, go through some simulation, and then go through some troubleshooting techniques. Let's get started. So now what I'm going to do is I'm going to go ahead and pull up my RSLogix 5000. And if anybody has any questions, you can feel free to just chat in, and I'll grab them when I'm at a stopping point. So we'll go from there. Okay, so the first thing we're going to do is we're going to open up a sample project. I've already had my sample project open, and what we do is we just go down to the 69 bus, add a module. We're going to go ahead and grab the other, and it's going to be a generic 1769 module. We'll go ahead and add that in. Go ahead and name that 69 MCM. Okay. Now this is an important thing. We want to make sure that this is not an input data int. It's a data int. So it gives us output also. Size. There's three different sizes for the CompactLogix. There's 60, 120, and 240. It kind of depends on how much data you want to push across the backplane. Generally, people use 60 words, so that's what we're going to go to today. So we're going to do input words of 62, output 61, and go ahead and hit OK. RPI, we're going to just go ahead and leave that at 2 and go from there. So now we've added our module. Now we'll go ahead and go through importing the add-on instruction. So what we're going to do is we're just going to go ahead and go into the main routine, right-click on an empty rung, and import rungs. And I have the add-on instruction. Where is my add-on instruction? Okay, well now's the perfect time to go to our website and grab the add-on instruction right from our website. So here's kind of an overview of our website. So we'll go to Products, Rockwell, Platform, and then Browse by CompactLogix. We'll go down to Modbus Master Slave. That'll be our serial module. Click there. This is an overview of our whole page for this module. And I scroll back up, and the download section is all on the right-hand side. So we'll go ahead and grab the add-on instruction. Go ahead and save that, and save that right to my desktop. So it's just that easy if you're missing something from the CD. All of our products ship with a CD, all the cables you need. But if something doesn't have it, or you want to check the website for the latest and greatest, you can always come to the website. We also have the configuration software here, which is free, and you can go ahead and grab that. We update that all the time, so you'll always have the newest one here. Okay, so now I have the add-on instructions. So now right-click on this, import rungs, and then grab the MVI69 MCM add-on rung. And we'll go ahead and import it. And now it'll bring up a dialog box. If it's not in slot 1, it's going to always try and push it into slot 1. So here's where we would change that if it's not in slot 1. Ours is in slot 1, so we don't have to go through and make any changes. But here's if you wanted to make some changes, you'd make that before you can bring it in. You can also go ahead and edit it later, so that's not a problem. And we'll go ahead and import that guy. And what that'll do is that'll bring in all our user-defined data types, our actual add-on instruction. In the main routine, it'll bring the call to the add-on instruction, and it'll also import our controller tags. So here's all the controller tags that it imports. Brings in all the local, which was done by adding the module, and then it brings in the add-on instruction, MCM, connection input and output, and then all the MCM. This is kind of brief overview of the controller tags. It goes over the config, which is the only thing in here is the block transfer size. Right now we have ours set to 60, so this will be fine. MCM data. Now this is where you're going to see your input and output data. We don't actually reference the local tags. We use the read and write tags. We do that because we use paging across the backplane to the processor in blocks of 60. So if you would add data to these, it would actually interrupt our block transfers to the processor. So that's why we provide the read data and the write data tags. So that's that. So now we can go ahead and go to download this. So my processor is IP address 246, and we'll go ahead and download this. Go back into run mode, yes. Okay, I'll keep going over the controller tags. So we have MCM status, pass count. This is a nice one to just see if the module's talking across the backplane to the processor. Every time it gets a block back and forth from the processor, it increments this by 1. So you'll see this always chugging along. Some of these port 1 stats will have a command request, response for the port. So it goes through a couple different various statistics for each port on this module. Here's just more block transfer sizes back from block transfers to and from the processor, and that's really about it. And control. This is where if you needed to warm boot or cold boot. We also offer event commands and command control. That's kind of getting a little more into programming and timing for when if you want your commands to go out. The event commands, you basically build your own command inside Logix, and then you tell them when to go out. Command control is you would build the command in the prosoft configuration builder, but leave it disabled, and then you can go ahead and toggle them from ladder logic. And basically more statistics. So now that we're done with this, I'm going to check and see if we have any questions. If not, then I'll just go ahead and go into the configuration of the actual module. So it doesn't look like we have any questions. So now I will go into our prosoft configuration builder, and I'll go over adding that module to the prosoft configuration builder and go ahead and configuring it. So we'll go ahead and click on default location, add a module, and we'll go choose module type, and we'll filter it by MVI69, and then the drop-down menu we will choose the MCM. Go ahead and grab that. Leave all these checked. That'll enable you to edit each one of those. We'll go ahead and expand this. And first one we'll look at is the backplane 69. This basically lays out how the data is going to be allocated. It's going to have your read register start, which that's where all of our data coming into the module is going to be in that location. So from 0 to 240 is our read data, and from 300 to 540 is going to be our output. So I'm just taking a note of that, so when I go ahead and do my commands, I can reference that easily. Also, we have the backplane fail count. It'll stop communicating if it doesn't get communication in the processor X amount of times. Error status pointer. Initialize output data, we generally leave that to a no. And here again, you'll see a block transfer size of 60. That comes up a couple times because, like I said, there is 3 of those that we can choose. So now we will go into, and if you have to edit anything, you can expand this and configure. So if you have to edit anything, but we'll go over that down here. So now we'll go into MCM port 1. We're going to go ahead and edit this one and make this a master. So we want the port 1 to be a master. So we'll go into configuration, enable, yes. So we want to do a master. Float flag we'll leave no. That's more for a slave type scenario if we don't have any control of where Enron Daniels floats are coming in, something above 47,000 that we don't actually have access to. So we'll have to say yes here and then redirect it to where we want it to go in the float offset. So that's just FYI. Protocol we're going to be using is Modbus RTU. Baud rate, we're going to bump that down to 9600. Parity none, data bits 8, stop bits 1. That's typically whatever device you're going to be communicating with. We need to follow those settings here. RTS and CTS, those are going to be for more like a radio communication if you need to set a high or keep a high after communication for a certain amount of time. We can compensate that here. Command count, how many commands are we going to actually have for this MCM master? I'm just going to leave that at 1. That'll be fine. We'll just set up 1 command. Minimum command delay, if we need to have a delay in between each command, say we have, we're just sending 2 commands to 1 device and that device doesn't like to get hammered away, we can increase some time, or if we have a couple devices we can increase time, and this will go over the entire command list. The command error pointer, this is a really handy one. I recommend everyone setting this up when they're first getting the ball rolling with their devices. So I'm going to go ahead and change this to 100. And the reason why I pick 100 is because that's inside my read array. My read array was 0 to 240. So I'm going to just put it in at 100. I can clear that out later once I know I have valid communication. Response timeout, this is going to be how long we're going to wait to hear a response. Retry count, I generally push this to 0. Just because if they're not going to respond, they're not going to respond. No sense in holding up the entire network for just 1 node. If that node's offline, maybe they're just servicing it. Okay, so then we'll click OK there. And now we'll go down to our Modbus port 1 command. We'll configure that, and it brings up a edit window. We'll have to add a row, and double-click that, and we'll be able to edit that row. So now this will be our first command. So we'll go ahead and enable yes. We also have a conditional. Basically, a conditional is it only works on a write command, and if any of the data changes that's allocated with this command, if any of that data changes, then it'll write that command. So devices that don't need to be written to all the time, and no sense in doing that. So we can just change it to a conditional and write it only on data change. But for this test, we're going to just leave it as a yes or a continuous. Internal address. I'm going to set this up as a read command. So I'm going to leave my internal address at 0. Poll interval. This is to if some devices require or some commands have a higher priority, you can leave this down at a 0 and bump your other commands at a, let's say 10 or 100. That way, this command will get in more often than other commands with a higher poll interval. Register count, this is how many Modbus registers we're going to grab in this 1 command. So I'm just going to go ahead and bump that up to 10. Swap code, here's a good one. If you're going to be reading any kind of floats and there's byte swapping between us and that device, we can go ahead and compensate that here. We have a couple different ways we can word swap it. So it'll swap the first and second word and byte, which that'll swap the words and obviously the bytes, and byte swapping. So for now I'm just going to be reading integers, so I'll just leave that at no change. Node address, what's the slave ID of that device we're going to be reading from? Right now we're just going to be leaving slave ID 1. Function code, I'm going to be reading my function code 3, which is going to read 4x registers or holding registers. I'm going to leave that at function code 3. We also have, you can read coils, 3x registers, and then we have all our write function codes. Write coils, write multiple coils, write words, write multiple words. And the MB address and device, that's going to be where that data is located in that end device. So we'll just leave that at 0 just because we're going to run a simulator. And that looks okay, so we'll click OK on that. And now we'll go into editing our MCM port 2. We're going to make this one a slave. So we'll go ahead and go to the configuration, enable no. We'll change that to yes. We'll set this to a slave. A lot of the stuff we don't have to worry about. We're going to be using RTU still. Baud rate will change this to 96, none 8 and 1. The rest of this is kind of minus the slave ID. So we'll change the slave ID. We'll change that to slave ID 2. And here's offsets. If we're going to be getting any kind of data, say they're sending us a 30,001 and a 40,001, that's going to reference the same address in our module. So if we need to change that, we can change the output offset, word input, holding register offset to kind of compensate that. And it kind of goes over which function codes that's going to mess with. So if we need to change, we're getting something at a 30,001, we need to bump it up 10 registers. We can add a 10 here, and that'll separate that data. So we're stomping on the existing data from another command. So that all looks good. So we'll hit OK there. And now we're going to go ahead and download to this guy. So now I'm going to right-click on the module and download from PC to device. And I'm using COM2. And go ahead and download. So that takes a minute. Just download, and I'll go ahead and start a reboot after it's done downloading. And while this is downloading, I'm just going to go ahead and check if we have any chat questions. And it doesn't look like we have any chat questions. Okay. Okay, so now it's rebooting the module. And now the module's running. So now we can hit OK and minimize this. Okay, so now we still have our logics open. And now I'm going to open up a Modbus simulator, which this mod sim, we don't actually make this product, but we use it a lot here. We use this product all the time in testing. It's an extremely handy product we use. So our first command we were going over, and I'll just kind of bring that up so it kind of refreshes our memory. It's enable yes, internal address. It's going to store it in our first read register, and we're going to be reading from node 1 from its address 0 or 40,001, because using a function code 3, that's implying 40,001. And we're going to be reading 10 registers. So if we go over to our Modbus simulator, we'll go ahead and connect using port 2, 9600, 8, 1, and we'll change this to none, and RTU. I'll hit OK there. And we'll change, if you notice the address is 40,100. Well, we're trying to read 40,001. So once we do that, now we'll be able to open up our MCM data.read data, and we should be able to change these registers, and they'll show up in our read data. And we're grabbing 10 registers, so if I come over to this 40,011, we're not going to get that data. But if I go to 40,010, we'll be able to grab that data because I'm only reading 10 registers. Just point that out. So now if you want to go into some troubleshooting techniques, we'll be able to, well, let's do this first. So if I wasn't communicating with this module, I put in my command error pointer at address 100. So if we go down to our read data 100, you'll see that set as a 0. Now if I unplug the module, or unplug the cable that's communicating to that slave, you'll see that come up as a -11. Now -11 means timeout, waiting for response. So that's because we're not communicating with that device. So I'll go ahead and plug this back in, and you'll see that go back to 0 immediately. So that's a really handy tool going over the first time setup. Now that will also have different error codes. Some of them will do, let's say I am looking in the wrong location. So let's change this address in the slave to be looking at address 100. Now you see my function code has changed to a 2. That's because we're not looking in the correct spot. I don't have 40,001 on screen saying I don't have a 40,001 register. You're looking in the wrong spot. So now if we change it back to 01, now you'll see that it goes away to 0. So it'll give you a lot of different function codes, or a lot of different error codes, and all those error codes are on display on our user manual. So you'll be able to find those no problem. So now let's say if we have an error that's coming up and we don't know why, we can go into our diagnostics. So if you right-click on the module, and let's do this actually. Okay, so if we right-click on the module and go into diagnostics and go to the connection tab, connection setup. So now we're going to choose which COM port we're going to be using. I'm going to use COM 3, and we'll go ahead and connect. So anytime we can type a question mark, and that'll bring up the menu. To get into the data analyzer of this module, it's a little bit different than our other MCM modules. But here you'll see protocol serial for the MCM port 1 is actually 0. So we'll type a 0 here. Now it's saying protocol serial MCM1 menu. Now what we want to do is go to serial port S. Type in S, and data analyzer is one of the options. So go D for data analyzer. Now this is going to show you what it's set up as. Port 1, yes. Format is going to be hexadecimal. That's what we always recommend. That way it displays every character. Nothing's really hidden. And tick is a 10 millisecond tick. It's going to be a underscore TT underscore. So that's going to reference whatever timing. So we can see some timing in there. And if you have any questions on what menu you're at, you can type question mark at any time and it'll display the menu. So now what we're going to do is type B to begin, and now it's going to show Modbus Communication in display mode. So now if I go ahead and unplug it, now you'll just see our commands going out with no response. And you'll also see that, let me come over here. And you'll also see this went to a -11, seeing timeout. Now I plug it back in, now you see the data, and that 0 came back, saying we have valid communication. Unplug it, we just had the commands. Now let's see here, type S to stop. This is basically the structure of the Modbus command. So we're trying to talk to slave 1, using a function code 3, trying to dump it to address 0. And this is the checksum. So we can see the request going out, but we don't see any responses. So this is kind of a pretty valuable tool. If you see any noise on the line, that would be referenced into highs all the time, so like FFs you'd see a lot of in the response. And you notice that all our requests are in angle brackets. And if I go ahead and start this again, stop it, you'll see the response is in square brackets. And that'll always be the case. Anything coming from us, you'll see on our data analyzer in angle brackets, and anything you see coming in will be in square brackets. Now this works if we're a slave or a master. That doesn't matter. We always have this feature available. So now let's go into, so pretty much done here. Let's go back to, and if you want to type M to get back to the main menu, I always recommend doing that because if you do run the data analyzer, it will slow down your communication on that port. So I always type M to get back to the main menu. And now we're at the MCM main menu. There's a lot of other stuff in the analyzer or in the diagnostics view. You can see database view. You can see a lot of different stuff. You can warm boot the module from here. So it's a pretty helpful tool that we offer. So now that's okay. So now let's say we want to be a slave. So on our port 2 is set up as a slave. And there's another tool, it's ModScan. Now ModScan is going to be a Modbus, serial Modbus master simulator. So we'll go to connect. We're going to be using COM3. If you notice, I'm using the same COM ports. I'm just switching them around here manually. The baud rate was 9600, 8, none, and 1, so that's fine. And we'll click OK. So now we're going to be reading, let's see, why is this timing out? 10. Okay, so then we'll go to holding registers. Okay, so let's go back into our configuration of port 2. Set up as a slave, 9600, none, 8, 1, RTU. Here we are. Slave address 2. This is set to slave address 1. That's why we're having the issue. So now if I change slave address 2, now we're seeing all that data. So let's see, let's change this display options to integers. And so now you see we can now write to this data. So there, now we see the same data on all 3 of these, now saying that we have all this communication. Now we can write 3, and it shows up in the correct location. So there's kind of setting up as a master talking to a mod sim, which is a server or a slave, and a master of ModScan talking to our slave port 2. Now you notice they're both sharing the same database, which is common. We just have to make sure that we allocate enough buffer space in between each command and each port. So now let's see. And that's pretty much the overview of the MCM. Let me see if we have any other questions out there. No, there's no questions out there right now. So that's pretty much it. We'll go over went over the website. That's fine. Yeah, so that's pretty much it. If you guys have any other questions, you can always call in on. We have a ton of different offices. Let's see. So here's all our offices, phone numbers, and email accounts. If you have any questions anytime, give us a call, email us, or chat. This is all going to be on our website on the Contact Us portion. And thank you guys so much for coming. And if you guys have anything else, feel free to let us know. That's it. You guys have a great day. Thanks again.